So in Chapter 8, one of the things that we're going to start to look at is what's known as a confidence interval. And a confidence interval, some basics here. So in just looking at this first paragraph here, our goal in many statistical settings is to use a sample statistic to estimate a population parameter. In Chapter 4, we learned if we randomly select the sample, we should be able to generalize our results to the population of interest, meaning we use samples to try to make some sort of estimate about some value that's in the population. What we just did in the previous chapter was we took different samples and we took some of the different things that we knew about the population and we tried to use that information to predict the probability of different things that would happen within our samples. In this chapter, one of the things that we will learn about is what's known as a statistical inference, known as a confidence interval. And a confidence interval is a way to estimate the value of a parameter that you get from a sample statistic. So one of the things that we will do here with confidence intervals is we will take a sample from the population and we will try to create an interval that we feel will capture what the true population value is from that sample. So an activity we're going to do on the first day of class with confidence intervals is what's called the mystery mean. So what I have here, and this is coming from our calculators, is from a normal population there is a mystery mean that has a standard deviation of 20 and a sample size of 16, and the result from that is 240.79, meaning there's some normal population that has a mean of a certain value with a standard deviation of 20, and if we took 16 samples from that population and we recorded what the mean was 240.79. And one of the things that we'll start off with our first day of class is looking at this activity and trying to come up with a interval for which we think would encompass what this mystery mean is. So we're going to reference this here in a couple examples that we're going to look at sort of moving forward. So some terminology that's involved with confidence intervals, one of which is what's known as a point estimator, and that's a statistic that provides an estimate of a population parameter. The value of that statistic is what's called a point estimate. Ideally, a point estimate is our best guess at the value of an unknown parameter. So a point estimator is the name of the statistic, meaning the sample mean or the sample standard deviation or the sample median, something like that. The point estimate is what that actual value is. So we learned in Chapter 7 that an ideal point estimator will have no bias. So remember, bias refers to accuracy and low variability. So keep in mind we're measuring variability with standard deviation. Since variability is almost always present when calculating statistics from different samples, we must extend our thinking about estimating parameters to include an acknowledgement that repeated sampling could yield different results. So remember that whenever you're taking a sample from a population, there's no guarantee that if you took a sample and the results that you get would be the same as if you did the same process again. So an example of some different things involving point estimates and point estimators is a question like this. So what we're looking to do here is we're looking to first just determine what the point estimator is and then what the value of that point estimator would be, which is the point estimate. So part A here says quality control inspectors want to estimate the mean lifetime of the AA batteries produced in an hour at a factory. They select a random sample of 30 batteries during each hour of production and then drain them under conditions that mimic normal use. And here are the lifetime in hours of the batteries from one such sample. So you have 30 batteries here and what their life what their lifetimes were measured in hours. So we're looking for what's the point estimate or what's the point estimate here. So for something like this, we would want to use the sample mean as the point estimator, x bar. And then the point estimate would be, what is the value of the sample mean? Well, if I added all these numbers up and divided by 30, this comes out to be roughly 16.7 hours. So that's the point estimate. So the point estimator is the name of what we're going to calculate. The point estimate is what that actual value is. So that's just some different things with those two terms for Part A. For Part B, the question says, what proportion of U.S. high school students smoke? A 2007 study questioned a random sample of 14,041 students in grades 9 through 12. Of these, 2,808 said they had smoked cigarettes at least once a day in the past month. So once again, we're looking for what's the point estimator and what's the point estimate for this value here. So keep in mind with this, we're talking about categorical data here. So we would want to use the sample proportion as the point estimator. In that case, we're talking about p hat. And then the point estimate would be, what's that value of p hat? So to find the value of p hat, we would take this 2,808 divided by 14,041, which comes out to be roughly 0.20. And then for Part C, we're going to reference the values that we had in Part A, and it says the quality control inspectors in Part A want to investigate the variability in battery lifetimes by estimating the population variance. So remember, variance is simply just the standard deviation squared. So if I wanted to find what the standard deviation of all 30 of these values were, the easiest thing I can do there is to take all 30 of these and put them in the L1 column of your calculator and then do the 1var stats. And then when you do that, the value of, sort of fast forward here, the value of Sx would be the value of the sample standard deviation. So in this case, the sample variance, which would be the sample standard deviation squared, that would be the point estimator. That's the name of the value that I'm going to compute. And then if I computed what that value was, this comes out to be 0.508, and that is the point estimate. So just some different things that we do there with terminology involving point estimators and point estimates. So of some different things with confidence intervals, and I'm referring back to this mystery mean again, and it says the value of the population is the value of the population mean exactly 240.79. That was the value that they got from the sample size of 16 from that population. So now, since once again sampling has variability, the chances that the mean is exactly that number is not very good. So the question then becomes, how close to 240.79 is the population mean likely to be? So some different things that we would investigate when we're talking about this is the shape, the center, and the spread. So the shape of this would be normal because we know that this sample of 16 comes from a normal population there. So in that case, since the population distribution is normal, we can assume that the sampling distribution is normal. The mean of the sampling distribution is the same as the mean of the population distribution. Unfortunately here, that is what we're trying to figure out from this problem. And the standard deviation, since I know that the population standard deviation is 20, I can find the sample standard deviation by doing 20 divided by the square root of the sample size, which in this case was 16. So we would say that the sample standard deviation in this case would be 5. So if we're talking about just comparing some different things with this and the normal curve, if you take a look here on the left, is what you have is the population distribution for this that has some unknown mean in the middle and a standard deviation of 20. And if we take simple random samples of size 16 from this population, we would get a sampling distribution that looks like this. So you can see that because the sample size in this case goes from 1 to 20, you can see that this graph starts to look more normal than the population distribution does. And if I were to increase the sample size from 16, then we would notice that that graph would look even more normal than this one does here. So in terms of using confidence intervals, one of the things that we'll look at here is the empirical rule, which, if you recall, the empirical rule is the 68, 95, 99.7% rule. So remember that in terms of what some things we know about the normal curve, we know that in terms of the 68% part of this, we know that 68% of data values under the normal curve fall within one standard deviation of the mean. We know that under the normal curve, 95% of data values fall within two standard deviations of the mean. And then this 99.7 here, we know that under the normal curve, 99.7% of data values fall within three standard deviations of the mean. So if we were going to use the 95% part of this to create a confidence interval of size 16, remembering that the sample standard deviation for this would be 5, what I would end up with is some sort of value for the mean in the middle, and then if I was going to go two standard deviations above and below the mean, I would take whatever that value of the mean was, and I would add 10 to it going this way, and then I would subtract 10 from it going this way. So as far as what we're going to use here, what we're going to use, since we don't know what the population mean is, we're going to use this sample mean in its place. And if I take that sample mean and I put it in here, what I would end up with is this here at the bottom. And what we would estimate is that mu lies somewhere on the interval between 230.79 and 250.79. And we would be calculating an interval using a method that captures the true value of the population mean in about 95% of all possible samples of this size. And one of the things that we will get into looking at as we kind of move through confidence intervals is we'll look at some different things involving how you compute a confidence interval, as well as some different things with what a confidence interval means when you compute it. So in terms of the main terminology that's involved with confidence intervals, what we have here is this. The estimate that you get from a confidence interval is essentially the value that you get from your sample, and the margin of error that you have in a confidence interval comes from the amount of variability that comes from a sample. So some terms that are down here, and these are very important when we're talking about confidence intervals, but a confidence interval for a parameter has two parts. It has the estimate, which is the value that you get from your sample, and then it also has the margin of error. So the margin of error tells us how close the estimate tends to be to the unknown parameter in repeated random sampling. And that's usually measured with the standard deviation. Your margin of error is a part of how we find the margin of error. The confidence level, which we're going to use as the variable C, the overall success rate of the method for calculating the confidence interval. That is, in C% of all possible samples, the method would yield an interval that captures the true parameter value. So the most common type of confidence interval that we compute is usually a 95% confidence interval. So in terms of what your confidence level is when you compute a confidence interval, most problems will give you some type of level to use. If you do not have a level that is given, we typically use a 95% confidence interval. And your confidence level. Your confidence level, in terms of how it changes from 95% either higher or lower, is based upon what type of sampling you're doing. But usually what you'll notice is that a 90% confidence level is usually the lowest that you'll see in terms of some different things that we do with confidence intervals. So that's essentially the sort of the basics behind some different things involving confidence intervals. What we're going to look at next is going to be some different things with how to interpret both a confidence interval and what's also called a confidence level. And we'll get into some different examples of how you compute a confidence interval, both with your calculator and also without.